Hi, my name is Kareem Eliawi, and today we're gonna be I'm gonna be showing or teaching how we can find water accumulation doing hydrological analysis. So to start with, um, I downloaded my data from USGS, which is for rasters, like you see here, and then I need to merge these rasters so I can work with the whole thing at once. So for this step, we will use merge rasters, and we're gonna add all our raster images that we downloaded into this, and we're gonna create a new raster. So here for the resolve overlap, it doesn't matter what you choose. So we're just gonna leave it with the first and hit create new layer. And this should merge all these four rasters into one, and we're just gonna work with it. So like you see here, and even took care of the overlap there. So now it's one image. All right, so to start with our analysis, um, we're gonna look for the flow direction within our raster image. So we're gonna use the merge raster. So we'll check for the flow direction. We'll just call it one. All right, and just leave everything else and hit run. So after running the flow direction, we're gonna go ahead and look for the sinks. So the flow direction, um, it is a tool that helps us to create a raster from its cell to its downslope neighbor using the D8, the multiple flow direction. So after it runs, right there. So now after we run the flow direction, now I need to identify the internal drainage, which called the sinks within the flow direction raster. So for this step, we're gonna use the sink tool. So we'll type in sink, and we always choose the spatial analyst tool. So we'll use this flow direction, and then we call it sink flow direction. Sink flow. Let's do sink flow, and then hit run. And yeah, it takes time to run. It's a bit slow, but anyway, for this sink flow, after we run it, we will need to change all this. We will need to change to create actually DM with the sinks removed. So we're gonna basically run another tool called the fill tool to help us fill all these sinks, all these spots right here. And you see, it kind of delineates all the watersheds and is looking at where the sinks are. So now we're gonna fill all these points here. So to do that, we're gonna run the fill tool. So, and we always look for the spatial analyst tool. So we're gonna throw the sink flow here. Field sync. We call it field sync and hit run. So all the sinks will be changed to match the elevation value of the lowest cell next to the sink. So the new DAM will be part of at least one continuous decreasing path of the cells, leading to an edge of the data set. So after running the fill, okay. So after running the fill, now we're gonna need to run another flow direction. And to do that, we're gonna use the flow direction tool again. Flow direction tool again. And then we will use the fill sync to run this flow direction. And then hit run. And after we run the flow direction again, we will have to run the flow accumulation to be able to see where water is possibly to accumulate. And if you notice, it's going targeting all the streams. So it's gonna. So after running this flow direction, we need to run the flow accumulation to create a raster layer that indicates where water is most likely to accumulate. So we'll do flow accumulation. So we'll just leave everything the way it is, and we'll just run this flow accumulation tool. And this will show us where the water is accumulating. Yeah, it takes time for it to. So yeah, so this is all the spots where water is supposed to accumulate on this raster. This is like, if you look at the attribute table, Yeah, that's almost 138. So yeah, this is how we define the water accumulation. Uh, you, once we try to once we try to do hydrological analysis.